So for this talk, I'm going to preface the issues with planet formation, the origin of planets, with people who are, what society would consider experts on the issue. This is a direct quote in the introduction in their paper called Challenges in Planet Formation. I read this out to on another video, but apparently it's not going through people. My new listeners, this is going to be a lot to take in, who have just recently learned about this theory, but a couple points I want to make here, how I know that planets are ancient stars. Hi Celeste, I know you're at a barbecue right now, and you're seeing this. I don't know if you're going to make it past the first minute, because this is definitely going to be a sleepy talk. But in the introduction, it says here, quote, "The origin of planets is a vast, complex, and still quite mysterious subject. Despite decades of space exploration, ground-based observations, and detailed analysis of meteorites and cometary grains," quote, or in parentheses, the only space samples available in our laboratories, "it is still not clear how the planets of the solar system formed." This is experts saying this. Experts. "The discovery of extrasolar planets has added confusion to the problem, bringing to light evidence that planetary systems are very diverse, that our solar system is not a typical case, and that categories of planets that don't exist in our system are common elsewhere, e.g. the super-Earth planets." Now, there wasn't anything confusing about that statement. Hopefully, they didn't know how planets are formed. It's vast, complex, and mysterious. And then the exoplanets added confusion to the problem. It is still not clear how planets of the solar system formed. Now, why are people telling me that they know how planets form if the experts say they don't know how they form? It's still mysterious to them. Does that match up? No, it doesn't match. The truth about it is that planets are ancient stars, and this is how I know why. Take a look at this. This simple graph here, or diagram, overviews phases of matter. You have plasmas, gases, solids, and liquids. Enthalpy goes up. That's basically, it's a fancy word for heat. The hottest objects are composed of plasma, and then the plasma recombines into gas, and that gas condenses into liquid or deposits a solid, and then that liquid also freezes into solid. So as the heat is removed from systems, they undergo phase transitions. Plasma becomes gas, the gas becomes liquid or solid, and then liquid becomes solid. So this is what we should expect the lowest energy system to be composed of, is solid material. And the intermediate age systems are gaseous and liquid. And the very highest energy systems, the systems that are the youngest, the most energetic, they haven't had the time to lose their heat from the birthing of the object, they're going to be composed of plasma. This is one of my earlier favorite graphs Baz had made for me. Check it out. I reinterpret the population versus Gatei's populations, which are based off metallicities, which is, Big Bang creationism nonsense. You don't have to worry about that. The actual populations of stars that I have in this theory are population 1, which is the plasma and stars in the visible light spectrum. These are all the stars that the astronomers call stars. These are the ones that have been classified, and an Ouroboros has been made that's still taught in universities that makes only the visible stars evolve and become other types of visible stars. This other half of the diagram over here, okay, that part we can ignore. Astronomers only look at the stars as being the ones that shine. But herein lies the problem. We know plasmatic material becomes gaseous, it recombines. It undergoes a phase transition, which is an exothermic reaction. Recombination is an exothermic reaction, meaning heat releasing. That's why the stars are shining. When they're done shining very brightly in the visible spectrum, they become gaseous and liquid matter, or mostly gaseous. It says here, population 2, gaseous matter that no longer has strong visible spectrums. These are what the gas giants are. Gray dwarfs, Jupiters, late-stage brown dwarfs. Brown dwarfs straddle the area between population 1 and population 2. These shine really brightly in the infrared, but they are intermediate H stars. They're what Anthony Abruzzo had mentioned as the missing link stars, if you will. Now, if you continue on, what happens to liquid, or what happens to gaseous material? Well, it continues cooling and undergoes what's called condensation and freezing. And that gaseous material goes right down here. And it becomes ocean worlds, late stage Neptunes, Earths, and of course all the dead stars that are down here. This is a much more completed diagram of that same process because I had to include a lot more dead objects in there, and I also included all the smashed up stellar remains. But as you can see here, that's how I know planets are ancient stars. It's because of phase transitions. The material loses its heat and energy, and its size decreases as it loses its mass. Now, I know astronomers say, well, the sun can't lose all that mass. Well, the direct observational evidence of the sun having lost all its mass is the fact that we have observations of old stars that have lost all their mass. The astronomers call them planets. They're not different at all. They're the same things. Astronomers, what they do is when they draw up their equations for stellar structure, they reference them as being closed systems. So what they have is only exchanges of energy. So you have that little red area where all the light and heat energy is exchanged, but they don't have stars like the sun losing any appreciable mass as it evolves. They don't have any object that has a bright visible spectrum as losing any mass as it evolves. All these objects to astronomers are closed systems, but that's completely false. Stars are open systems. They exchange both energy and matter with their environment. That's why I know they can lose mass. Not to mention that they're observed to have lost all their mass. The semantic issue of calling old stars planets is still there, but it gets in the way of astronomers understanding the very basics of what it is they're looking at. Of course, dogma, it remains dogma for a very long time until, people start realizing, something like this, something as self-evident as this is more than likely the truth. That's how I know. Another reason why I know is gyrochronology of stars. Their total axial angular momentum, meaning the spin energy of the star. There's a smooth continuum that stars travel along. The very hottest younger stars lose their spin energy as they lose their mass and as they cool down. And you can plot their ages over here. What is that age? Yeah. Their ages to what I call the Williams number on the very bottom. Stars that are going to have life on them are going to be around right here. A Williams number between maybe 10,000 to 706. That's where Earth is. Once it gets to Mars, the spin energy is a lot less than Earth. That's how you know it's basically dead. And then you have Venus. That's died a long time ago. And then Mercury. And then these objects right here are destined to move down this little graph right here. To move down this little line of evolution. The spin energy of a star diminishes as it ages because it loses mass and it experiences tidal friction with the objects that it orbits over a long-term period of time. And when it exchanges orbits with other stars, as those stars lose their mass, it sort of gives you an idea of what its past history was. And there's a lot more to this when it meets the eye. That's basically the third or fourth reason I have now. Fifth reason is that their mass and radius also plots on a single graph. Here I have a couple hundred stars from the Kepler data. Here's the mass versus radius. So you have the mass on the y-axis and radii on the x-axis. That's in Jupiter radii, and then you have mass right there. So as a star loses mass, it shrinks, becoming what's called the planet way down here. And all these are very young planets or young stars or what have you. This is very, very, very simple to understand. And last but not least, a sixth reason, but I mean, there's so many other reasons that have been piling up over the years. It's overwhelming talking about all this, and all my old listeners, they already know this. But you have endothermic reactions and exothermic reactions. This is direct observational evidence that the majority of the chemical reactions that happen in interstellar space happen inside the star as it evolves, which are mostly exothermic reactions. So you have a lot of the material, a lot of the elements that are in their ionized state. When they do phase transition to the gaseous form, they do overcome that hump. And how they overcome that hump, that activation energy, is through the energy of gravitational collapse. So the energy of the entire star squeezing on itself allows for chemistry to occur in the star as it cools and collapses and forms what are called molecules and compounds. And over many billions of years of this process happening, the compounds get more and more complex. So basically, the star is the object, a dissipative event that allows for life to form on it many billions of years into its evolution. That's absolutely phenomenal. And it's a tragedy to see people telling me that something like this can occur when in fact it is the truth. This is exactly what happens. So you have the activation energy overcome by gravitational collapse, which of course feeds a whole bunch of other different types of energy transformations. So gravitational collapse fuels a lot of friction, a lot of heat energy, and then you have heat fueling a lot of electrochemistry, and then you have thermochemistry. A lot of thermochemical reactions can occur due to gravitational collapse, squeezing the star and causing those chemical reactions to happen on a very, very large scale. And we can see that chemistry inside of Jupiter's atmosphere. I mean, if anybody has ever seen Jupiter, how wild that atmosphere looks. That's large chemistry happening. It's big chemistry happening inside of Jupiter. It's happening inside of Neptune, inside of Uranus, inside of Saturn. It happens inside of all stars as they evolve. And of course, I kind of want to dedicate this talk to Ing Lehman. Ing Lehman, this lady right here, she was born in 1888 and lived 1993. This lady right here discovered that the Earth has a very solid inner core. Without this lady right here, this theory wouldn't even exist, because the fact that she discovered that there was an inner core to the Earth was what I needed to understand, and the fact that the stars, they form fat as they cool and collapse on themselves. So this lady right here allowed for a lot more interesting things to happen, and she's just sort of not talked about on a lot of astronomy channels, regardless of Earth, and understanding the structure of the Earth is essentially astrophysics, because Earth is an astrophysical object. So that sort of goes right over a lot of the mainstream YouTubers, right over their heads. But anyways, I think I made this talk long enough. That's how I know planets are ancient stars. Later, y'all.